Okay, so here are the supplemental notes for section 6.4 for pre-algebra. The section is proportional, non-proportional relationships. So the whole point of this section is just kind of learning how to evaluate whether or not, if you look at two relationships, are they proportional or not. So the definition of proportional relationships is two quantities are proportional if they have the same constant ratio or rate. So if you keep dividing one by the other and they have the same thing all throughout, it's going to be proportional. Now, the book always tries to do like, well, actually it doesn't matter what order it does, minutes versus yards. They could do 300 to 1, 600 to 2, 900 to 3, or 1200 to 4. Or they could do 1 to 300, 2 to 600, 3 to 900, 4 to 1200. It doesn't matter either way. All of them reduce to the same thing, either 300 over 1 or 1 over 300. So this first example here, asking whether the distance traveled is proportional to the time, the answer is yes. The ratio for all of them is 1 to 300, all four of them. And again, they did time over distance. They could have done distance over time. Doesn't matter which order they go with it. If they do distance over time, what that gives you then is 300 over 1, still constant for all of them. Now for example 2 here, same exact idea. Excuse me. Take one quantity divided by the other, and again the order doesn't matter as long as you're consistent. So when they chose to do 15 over 10 for their first one, they had to do 30 over 20, 40 over 30, 55 over 40, 65 over 50. That had to happen that way. And when they do that, they get 3 over 2, 3 over 2, 4 over 3, 11 over 8, and 13 over 12. All 5 of those, well, 2 of them are the same, but the next 3 are different. Therefore, it's not proportional. So homework basically consists of doing like a few things: creating tables and filling them out if they're proportional, determining if they're proportional, and then using that to do something with it. So let's see here. Let's look at, I don't know, it doesn't really matter. How about let's go with cookies versus cupcakes. Let's do a food one. So cookies versus cupcakes. So what we're going to do is we're going to take these values and just put one over the other in the same order over and over again and see if they come up to the same ratio. So 6 to 4. I don't really have a ton of space here, do I? I'll just put it down here. Can I fit it in there? Yeah. So I have 6 to 4, which 6 over 4 reduces to 3 over 2. Okay. 9 to 6, divide both of them by 3, I get 3 over 2. 12 to 8, divide both of those by 4, that gives me 3 over 2. And 15 to 10, divide both of them by 5, I get 3 over 2. So yes, they're all the same. Ratio is 3 to 2. So it's actually a two-part explanation. One is just saying what the ratio is, and the other thing you'll need to do is give me the work to get to that. You can't just say yes and then throw some number out there out of nowhere. You have to do all 4 and show that all 4 are the same. Okay. Now the second type of problem is actually taking that proportional relationship and using it for something. So, for instance, we got this problem here from just kind of a practice problem. The perimeter of a square with a side of 3 inches is 12 inches. A square's perimeter is proportional to the length of one of its sides. Write an equation relating the perimeter of a square to the length of one of its sides. What would be then what would be the perimeter of a square with 9-inch sides? So there's two questions here. One is to write the equation. 2 is to figure out the perimeter then, given you know it's got 9-inch sides. So we have to find our constant of proportionality, which we talked about in class. The constant of proportionality is that rate, that constant ratio or rate. So they're wanting us to compare perimeter to the length. Okay. Well, perimeter was 12, length was 3, so 12 over 3 is 4. So our perimeter is 4 times the side length. That's the equation. So perimeter is 4s, perimeter is 4 times 9, 4 times 9 is 36, therefore our perimeter with the side length of 9 inches is 36 inches. Okay. So we'll just pick one of these, I don't know. Let's see which one works nicely. How about babysitting? Do is this too. Give me a moment. Give myself plenty of room. this out of the way. There we go. Whoops. Got a little meter for you. Right. So Gloria earned $26 for babysitting 4 hours. Write and solve an equation to determine how much Gloria would earn after babysitting 25 hours. All right, so they want to know how much would she earn after babysitting 25 hours. Okay. So we already know it's this much for 4 hours. So our constant of proportionality is 26 over 4. When we do that, we get 6 1/2. So she's making $6.50 per hour. We're actually really kind of finding the unit rate here. She had $26 over 4 hours. That is $6.50 an hour. So her, I don't know, let's call it B for babysitting, is 6.50 times H. That's what she's doing. Each hour she works, she makes $6.50, so H hours. So the question is asking us, okay, how much would she earn after babysitting 25 hours? So B equals 6.50 times 25. And that's going to be what we're going to have to multiply out, 6.5 times 25. So 6.50 times 25, 5 times 0 is 0, 5 times 5 is 25, 5 times 6 is 30, add the 2. Drop the 0, 2 times 0 is 0, 2 times 10 is 0, carry the 1, 6 times 2 is 12, add the 1, 13. So 0, 5, 2, 6, 1, and there were 2 decimal places here, so 2 decimal places here. So if she babysits 25 hours, she can expect to make $162.50. There we go. And that's really all we need to look at for this section. So hopefully this helps.